Hello guys, welcome back to Tickle Mats. Hopefully you guys are having a good weekend. So today we have already finished the chapter 1 number bases from 5 modern mathematics this week yesterday. If you haven't checked out the videos yet, please do. And Saturdays are usually dedicated towards a question answering questions from you guys, where I have given the email address and also the Instagram ID for you guys to follow and tag, or maybe send me an email regarding questions that you really want to ask. So today there was two questions which one of the viewers asked me, and I'm going to explain both the questions, and it's going to be additional mathematics questions. So today the first question is the question goes like this. Berjaya company has four vacancies for senior managers where each job has an identical description. Five men and three women have applied for the position. Find the number of ways of selecting four people to fill the position. So this was one of the question asked. The answer is actually uh, we are going to select four people out of five plus three. Five out of five men and three women, which means five plus three is eight. So it's going to be eight choose four. If I'm not mistaken, it should be 70. So the question was that this particular viewer student, she or he asked me like, why is it choosing not permutation? So the the keyword for choosing question is always that you will find keywords like selecting or choosing. So when these words are involved, you can always think that it's going to be a choosing question. And for permutation, usually it will involve arrangement based questions in from 5 levels. So that is how you get to know if it's a choosing or permutation question. And five men and three women are the people who really applied for the position, which means like it's going to be 8% in total, and they need only four people to fill up the position. So it can be any combinations of these eight people choosing to, or where any combinations, and four are chosen in the combinations. So yeah, this was the first question. So the second question is that a particle moves along a straight line so that its velocity is meter per meter per second at time t seconds, and is given with a trigonometric function equation or formula. And this particular question has two parts, which is proving the velocity to be 2 sine t, and also sketching the velocity. So we are going to use trigonometry uh, to really answer this question. So first of all, let's write down the velocity function first, which is, they have given that vt is equals to sine 2t plus cos 2t minus 1 divided by cos t minus sine t. Okay. So before you guys even think, why am I even studying this velocity and this trigonometry functions? They are not really useful. I don't know why am I doing it. It's mainly because if you're intended to do any sort of engineering, a trigonometry function is going to be involved, and some sort of velocity is going to be involved also. So you are going to use it in the future, but just that you don't know yet. So let's start our part one, which is proving that Vt is equals to 2 sine t. So for this particular question, we are automatically, whenever you see identity, Trigo identities like sine 2t, cos 2t, or cos square plus sine square equals to 1. So the identities are always given in the exam. So these are one of two of many identities that you guys have seen in the class or you are always given. So this solving this proving equation is going to be always like you plugging in whatever is given and making into this function that they ask you to show. So let's just start up with so we know that from the formula sheet, if you look back, that sine 2t is actually equals to 2 sine t cos t, and cos 2t has a lot of version which are cos square t minus sine square t equals to 2 cos square t minus 1 equals to 1 minus 2 sine square t. So you will have something like this in your Trigo identity formula list. So let's plug in and let's have a look. So let us equate that Vt is going to be equals to, yeah, okay. Vt is going to be equals to, let's plug in for sine 2t, we are going to plug in 2 sine t cos t, because that is the only one which is given, plus for cos 2t we have a lot of version. So if you look back or think about it, think more about it, you will somehow understand the fact that I would say that you have a lot of version. You have cos 2t is cos square cos square 2 cos t squared minus sine t squared, and it's also equals to this and this. So you might be confused on what to use, but trust me, whatever you use, you will somehow get to the same answer, because everything is similar. But now you have to make sure you do a lot of practice, and with the practice you will become smart enough to find the particular uh, equation to plug in. So if you have a look, just a general overlook on this velocity formula, if you can see, if you compare your numerator and denominator, numerator has this minus 1 here, but denominator doesn't have. So then, which means somehow in the process of you plugging in sine 2t and cos 2t, you're actually eliminating this minus 1 somehow. So for sine 2t, we don't really have much choice. We are only given this particular identity, so just plug in. But as for cos 2t, we have a lot of options, like 3 options. We can use wisely. So just have a look which option might cancel off this minus 1. So if you use this one, minus 1 is going to be remaining there because there's no 1 to cancel off this. And if you use this one, minus 1 is going to be minus 2. It's not cancelling off again. But if you use this one, 1 minus 1 is going to be cancelled off. So we are going to use this function to plug in cos 2t. So let's have a look. 1 minus 2 sine square t minus 1, and then I cos t minus sine t. Equate. Now expand the formula. How to expand? Just simply expand, like take out the brackets. 2 sine t cos t is going to be plus 1 minus 2 sine squared t, and then minus 1 here, and cos t minus sine t. Okay, now if you can see, the 1 is going to be cancelled off and you're going to be left with 2 sine t cos t minus 2 sine squared t over cos t minus sine t. So now how to proceed? If you're very unclear, you can always look at the common factors so that you can somehow factorize it. So if you see 2 sine t cos t minus 2 sine square t, the common factor here is 2 sine. Okay, 2 sine is also in this formula and also in this formula. So we are going to bring out the 2 sine. So let's do that. 2 sine cos t minus, if we bring out this, it's going to be just sine t and divide by cos t minus sine t. So if you see now in this stage of equation, you can see that this 2 will cancel off. This 2 will somehow become 1. So then left with, this one will become 1. So we are left with 2 sine t. So then we can say that Bt is equals to 2 sine t as per our proof for part 1. And for part 2b, they have asked us to sketch this graph from 0 to for t0 to 2 pi. So we can always sketch the graph. Let us draw the graph here. Okay, as far as I know, you should be knowing the sine graph, but even if you don't remember it, I can always um, show you it here. So the sine graph is the graph where you will be drawing like this, and the cos graph is going to be something like this. Okay, so for the sine graph, always remember, if you times some number here in front without really changing the angle here, it's going to be changes only on the amplitude, or the, yeah, it's actually called amplitude somehow. So the height of the maximum and minimum is going to be 2. Okay, and this is going to be pi and this is going to be 2 pi. So if they ask you to plot until pi, then you should plot until here. If they're asking you to plot until 2 pi, then you should plot the whole graph until 2 pi. So when you do alterations in if you do ubahan towards the, let's say, angle, then the graph is going to be shifted upwards or downwards. So it's shifting is going to happen, shifting in the sense like maybe you're going to shift away from the x-axis, something like that. But if the changes are happening in front of the whole Trigo function, you're only shifting, you're not really shifting anything, you're just changing the values of the 1 into 2 or whatever number it has been times up with. So in this basic question, I would suggest that try to practice a lot of trigonometry function questions so that you will know which Trigo identity to use accurately and come up with the answer faster. And also remember the graphs. Don't mess up the graphs, because cos is this and sine is this and cos is this. So one formula I can tell you that this is sine is that if you see this, you can feel like this is s, some kind of s, backward s. So this should be sine graph. And if you see this, this is similar to c here, so it's going to be cos. Okay, so that's one of the trick that you can use. And always remember, if you're not if you're changing a value in front of the Trigo function, it's going to be changes on the numbers here. and if it's changes at the angle, then it's going to be just shifting of the graph. Okay. Yeah, guys, please do send your questions. And for additional mathematics, I'm only going to teach in English. Hopefully you guys understand, but even if you don't understand, please comment down in the comment section. I can always help you guys with other languages too. And also please do consider subscribing the channel. I will be uploading almost every day according to the chapters. So right now we are only covering up modern mathematics, but sooner or later I will be covering up additional mathematics too. And do consider sending your questions in through my email address takelmaths1227 at gmail.com, or you can also follow me in Instagram takelmaths1227, and just tag me in any questions from 4 from 5 additional modern mathematics. I'm always here to discuss. So the two students who asked about this question, hopefully I get to answer your question. And thank you.